Welcome to week 10. We are going to focus a lot on object-oriented testing in this week. A typical example of an object-oriented language is Java, and you have looked at some amount of Java in this course, testing aspects of some amount of Java, and I believe most of you are all comfortable with programming in Java. You could use any other object-oriented language. They are rich with several features that aid programmers to write beautiful programs that can do a lot of work for us. When it comes to testing at the unit level, almost all that we saw, graphs, logic, mutation testing, can be used for object-oriented programs. The only catch is when we are doing integration testing, and if my object-oriented programming language or my program has features that are rich of object-orientedness, then not all the techniques that we saw might smoothly extend or start working. So we will see things that are specific to object-oriented programs and testing those features in this week. So I'll start with introducing some of the object-oriented concepts, specifically those that we need for integration testing when we look at a particular method calling another method, and if that method is polymorphic and the column method, the callee method is polymorphic or the caller method is polymorphic and they belong to different classes, what could be the problems, what are the unique features that we need to test, and so on. So we look at some object-oriented features to start with today. And then, if you remember, last week we did mutation testing. So in the very next lecture, we'll quickly continue with mutation testing for object-oriented integration. So that's what we'll do in the next lecture. Then later, for the remaining 3 lectures of this week, we'll look at other concepts related to testing of object-oriented applications. So I'll begin with an overview of some of the object-oriented features that will be important for us for testing. This is purely with testing in mind, not to be viewed as an overview of all object-oriented programming concepts and design. Whatever we need, we will just basically present an overview of them. So while we do integration testing for programming languages that are imperative in nature, like C or other programming languages, we don't use several concepts. But when we apply the same integration testing for object-oriented languages, a lot of other features of object-oriented languages come into influence when it comes to testing. Some of them can apply within a method, that is, or between 2 methods in the same class, or some of them can apply between 2 method calls in different classes. In addition, the 2 classes to which the methods belong to could be parent and child, could not be related, and so on. So we will recap the following features when it comes to object-oriented testing, again purely with testing in mind. So we look at encapsulation, what it is, class inheritance, method overriding, variable hiding, what are class constructors, what is the notion of polymorphism, and what is overloading. Please note that I'll only be giving an overview of these concepts from the point of view of using them for understanding what are all the testing concepts related to object-oriented testing. So we look at them one at a time briefly. So to start with, encapsulation. So as the word says, encapsulate, cover up. It's an abstraction mechanism to cover or hide some information. It frees clients of an abstraction from unnecessary dependence on other decisions in the implementation of an abstraction. So you have a particular code that has a lot of details. When you encapsulate, you abstract out some parts of the code. So objects can restrict access to their member variables and methods by other objects, make it exclusive for themselves or make it available for other objects by using a notion of encapsulation. 4 access levels are supported as far as the object-oriented programming language Java is concerned, and these are the 4 access levels: private, protected, public, and default. Default is also called package synonymously, and because it's default, it is the default access. So this table will help you to understand the various access levels available in Java in a succinct way. So let's say a particular object is declared private. Then read this capital Y as standing for S, lowercase n is standing for no. So if a particular object is of type private, level private, then it's accessible within the same class and not accessible elsewhere else. It's all marked as no. So it's not accessible in a different class within a same package. It's not accessible in a different package subclass. It's not accessible in a different package that does not belong to a subclass. If a particular access level is marked as package, then it's accessible obviously within the same class. It's accessible within the different class, same package, not accessible elsewhere. If it's protected, then it's accessible within the same class, within a different class but same package, and within a different package subclass, and it's not accessible only in a different package that does not belong to this subclass. If it's public, as the name indicates, it's accessible everywhere. So it's marked yes throughout. So this is the notion, simple notion of encapsulation, and these are the access levels specific to a programming language like Java. Now let's move on and look at class inheritance. Let's say there are two classes, A and B, and B is a subclass of A. We say the subclass B can inherit a lot of things. It can inherit variables from the parent class or from an ancestor class. It can also inherit methods from a parent class or from its ancestors. After inheriting the variables and the methods, a particular subclass, let's say B, it can use them as they were defined in the parent or the ancestor class. It can override the methods, use new code for the method. It can also hide the variables based on what it wants to do in terms of its functionality. A programming language like Java specifically does not support multiple class inheritance. So you won't have things that are coming together from two parent classes into a child class. So every subclass or a child class has only one immediate parent. Different object-oriented programming languages can differ on this feature. Subclasses can also explicitly use their parents' variables that they inherit. The methods also they inherit. They directly can use it by using the keyword super, by prefixing the keyword super. So you say super.method name. This method with a particular method name belongs to the parent class. So Java's inheritance, class inheritance, allows child class to do method overriding, to do variable hiding, and it also allows the use of class constructors. What is method overriding? It allows a method in a subclass to have the same name as the method in the parent class, the same set of argument and the same set of result type as given in the parent class. Overriding allows subclasses to redefine the inherited method. So it will have the same signature. By signature, we mean the method name will be the same, the arguments will be the same, the return type of the result will also be the same. That's the signature. But the code corresponding to the method or the implementation of the method can look different in the child class. So this is what we mean by overriding a method. The variable hiding is another possibility during class inheritance. How do you do this? A child class that inherits a variable from the parent class can hide the variable. It defines the variable in a child class. It will have the same name. It will have the same type, but it can be hidden. The inherited variable, which has the same name and the same type from the parent, can be hidden from the child class by basically defining the variable once again with the same name and the same type. Class constructor is another concept that's used in class inheritance. A constructor is a class. In a class is a special type of subroutine that is used to create an object. It creates an object, prepares the new object created for use. It accepts arguments that the constructor uses to set the required member variables. Please note that constructors, this is not the same as the way methods are inherited. Methods that can be inherited and overridden. This is not the same way. To use a constructor, we must explicitly call it by using the super keyword. The call must be made in the first statement, right in the beginning of the derived class constructor, and the parameter list must match the parameters in the argument list of the parent constructor. Slightly different from inheriting a method and overriding it. The next is a notion of polymorphism. Polymorphism means one entity exhibiting two different forms of existence. There are two versions of polymorphism that a programming language like Java allows. One has got to do with attributes and the other one has got to do with methods. Both the versions of polymorphism use dynamic binding. In Java, each object has a declared type and an actual type. The actual type can be the declared type or any type that is descended down from the declared type. A polymorphic attribute is basically an object reference that can take on various types. At any location in a program, that is at any specific statement in a program, the type of the object reference can be different for different executions. So because of these things, I cannot statically determine what the call graph will look like when I use a programming language like Java, because each execution can behave differently. We will see a few examples down this week where this is illustrated very clearly. Like polymorphic attributes, we have polymorphic methods. Polymorphic methods can accept parameters from different types by having a parameter that is declared of type objects. So when I want to do type abstraction, I use polymorphic methods. A polymorphic method can take on different different code in different executions. And in Java, by statically looking at the class diagram and the methods belonging to the class, it's difficult to know which version of the polymorphic method will run if I have class inheritance. So a lot of things are dependent on dynamic execution. Couple of last concepts. Overloading. Overloading is basically use of same name for different constructors or different methods in the same class. They must have different signatures. That is different arguments. Please note, a few slides ago, we had looked at overriding. Overriding allows a method to have in the subclass to have the same name, same signature. By signature, we mean arguments, and result type must match that of its parents. What is overloading? Overloading is the use of the same name for different constructors or methods in the same class. But they all have different signatures. So the list of arguments that you pass, the return types, they are all different. So these two are different concepts. Overloading occurs within two methods in the same class. Overriding occurs between a parent class or an ancestor class and its descendants. Finally, we have instance and class variables in a programming language like Java. They are always associated with a class. Class variables that are associated with a class are also called static in the sense that they don't change. There is only one copy of the variable that is shared across all the instances of the class. Class is by itself not an executable entity. Instance of the class is what we use during execution, but it's the copy of the variable, the same copy of the variable that is shared across all the executing instances. On the other hand, instance variables belong exclusively to an object. That is, they belong exclusively to an instance of a class. Every instance of that class has its own copy of the variable. Is that clear? This is different from static. Changes made to the instance variable within a class don't reflect in other instances of that class. So instance variables are declared at the level of a class. Class variables are also declared there, but explicitly with the keyword static. Obviously, local variables, that is variables that are local to a method, are declared within methods. So just to summarize, we saw some overview of object-oriented concepts. This slide summarizes all the concepts that we saw. It was presented at a high level, mainly theoretically, without using examples, but you can always construct simple examples that will illustrate these things. We saw the notion of encapsulation, different levels, access levels in Java, the notion of class inheritance, again some notions specific to Java, and how do when I have class inheritance, how do I do method overriding, how do I do variable hiding, how do I do class constructors. Then we saw polymorphic attributes, polymorphic methods. Then we saw overloading methods. We will see a few more concepts, object-oriented design concepts later this week. But for now, to start with, for integration testing, this much is enough. So right in the next lecture, I will do mutation operators for integration testing, but specific with the presence of these object-oriented features. Just in the last week, we saw mutation operators for integration testing that were generic in nature. Now we are going to see mutation operators for integration testing specific to these features. After this, we look at some more object-oriented concepts that are relevant to testing and a few other design level testing for object-oriented programs. I'll stop here for now. The next lecture, we'll look at mutation testing. Thank you.